Lesson is section 2.3, and it's the last day of section 2.3, and we're going to be determining if functions are even, odd, or neither, because they don't have to be even or odd. So let's go ahead and jump in. So the first thing I want to say is if a function is even or odd or neither, it goes back to the symmetry. Okay, and if you remember that we looked at symmetry before, and the process that we're going to use to determine if something is even or odd goes back to the process we used to determine if a function was symmetric with respect to the x-axis, y-axis, or origin. So even functions, if we're thinking about them graphically, they are symmetric with respect to the y-axis. So I have an example here. You guys are more than welcome to just draw a regular parabola whose line of symmetry is the y-axis. So the one I have shown here is h of x is x squared plus 1, right? And you notice that, remember we had our normal, if I have a normal xy, for it to be symmetric with respect to the y-axis, it has a negative x positive y, okay? So algebraically what this means, and we're going to see how this goes again on my MacBook today, is that f of x, and we'll just, oh, that's not working out too well. Here we go. If it is symmetric with respect to the y-axis, or if it is an even function, f of x will be the same as f of negative x. Okay? So, or we could write it the other way, where if I have f of negative x, it will be the same as my original function. Okay, so the example we're going to use is the one here with the graph. That way you can see graphically what that looks like, and then algebraically what that looks like. So our example, again, if we are using, I'm just going to say f of x. Oh, that's really big. All right, so we're going to do f of x is equal to x squared plus, plus 1. So what I want to do, or what I typically do, is say, okay, I want to see what that looks like. So if I substitute a negative x, will it match my original? So here's my original function. So now I'm going to say, okay, what does f of negative x look like? So now let's substitute that in. So everywhere we see x, we are replacing it with negative x. So I have a negative x, that whole quantity squared, plus 1. Well, a negative 1 squared, because remember that's negative 1 times x, and negative 1 times a negative 1 is a positive 1. So x squared, and I don't do anything with that plus 1. So that's what I ended up with. And then we look at it and say, hey, do these two match? And we say, yes, they do match. So therefore, that's why this function is even. Okay? Now let's scroll down to an odd function. So an odd function is symmetric with respect to the origin, I think. Odd, origin. Okay, even is with respect to the y-axis, so I think of even e, like with a y on the end, even though I'm pretty sure that's not a word, okay? But it makes more sense, makes more of a word than even x does. So even e, because even's symmetric with respect to the y-axis. All right, so an odd function is symmetric with respect to the origin. So if we think about what that meant graphically, is if I had a positive xy, there would also be a point on my graph that was negative x, negative y. Okay, so algebraically, the function we're looking at is x cubed minus x. So algebraically, and I might try to type this in here, should work out better. If we have, oh, I don't think it's going to let me type. It's thinking. Well, I'll go ahead and say it to you guys. Okay. No, for some reason it does not want me to type on here. Okay, I will handwrite everything. If we have f, oh, there we go. Okay, taking too long. If I have f of negative x, so if I substitute negative x in for x, just like I did for the other function, but now if it is the opposite of my original function, meaning every sign is the opposite, which is why we have this negative out front here, then that means it's an odd function. Okay, so I want it to be complete opposite. So every positive will be negative and every negative is going to become positive. So let's take a look at this example here. So we have f of x equals x cubed minus x. Now, if this is an odd function, I'm going to write that over here. If it's odd, my function will be negative x cubed plus x. Okay, so I like to write that off to the side. That way when I get my answer, I can clearly see, does it match this response or does it match this response? And if it doesn't match either of them, then my function is odd. So let's substitute in f of negative x here. All right, so I get negative x cubed minus a negative x. Some of you are already like, oh, I know what it is. We're going to go through it. So when I cube a negative 1, that's a negative times a negative times a negative. So that is a negative x cubed. 2 negatives give me a plus x. So then I can look and say, all right, I am done there. Oh, I'm so glad my highlighter worked. Jeez Louise. Okay, there we go. So there's my function, and it looks like it matches this. So that's how we know that it is an odd function. Okay? All right. So we're basically going to be doing the exact same thing. Now, if you're looking at example 1, you're like, oh, that's the one I just did. You're right, so we're going to change it. We're going to make it slightly trickier, because why not? Since you guys always say that your turns are harder or more difficult. So the new function we're going to look at, I'm going to try typing again. No, not going to let me. Oh my gosh, it is. Oh, but I don't think it'll let me do. Won't let me do exponents, so it's not going to help here. Okay. So the new function we're going to look at, and we'll keep it g of x. G of x, you can just cross this one off, so we're going to do a different one since we just did that. It's going to be x to the 5th minus 2x cubed plus x. So that's my original function. And like I told you before, what I like to do is write the opposite of it, the negative g of x. So it's going to be, it would be negative x to the 5th. So we just switch the signs. And then it'll be a plus 2x cubed and a minus x. Okay. So now I'm going to go back, and we do this process for every problem. So I'm going to substitute in a negative x and see what I get. So I get negative x to the 5th minus 2 times negative x cubed plus a negative x. All right, so negative x to the 5th is just negative x to the 5th. Negative x cubed is still a negative x cubed, but now I have this negative times that negative, so that ends up being a positive 2x cubed. But do you notice how I cubed it first? I said negative x cubed is negative x cubed, so I cubed it, and then I multiplied. Remember, exponents before multiplication. And then plus a negative x is really just a minus x. So I look and say, oh, that's not matching my original, but it is the complete opposite of the original, so this is an odd function. Okay? Odd function. All right, so you guys have 2 your turns to try. I'm just going to write what the final result is after you substitute in your negative x, and then we'll determine if it's even or odd. So please pause the video, take a moment, just like if we were in class and I'm there with you. I would stop teaching, you guys would work on these 2, and then we'd come back together. So please pause the video, and then when you're done, come back and check your answers. All right, so I almost forgot to write what the odd function looks like. Sorry, I didn't do that up here, but the odd function up here would have looked like this. Okay, which it didn't match. All right, so now let's simplify this. We get negative x cubed. Well, that's still just negative x cubed. I have nothing to do with my minus 1, so it stays a minus 1. If I look, it does not match the original. And it also does not match the odd function, so this is neither. Okay, so to recap what you do to determine if a function is even or odd or neither. You substitute in negative x for x, simplify the expression. If it matches your original expression, it is even. If it matches the opposite of your original function, it is odd. If it does not match either of them, your answer is neither. All right, if you guys have any questions, be sure to let me know, and you're free to work on your practice work.